So good morning everyone, and thank you for joining me. My name is Alex Mackey, and this morning we're going to be discussing a brief history of cloud. Now, all the slides and materials I'm going to present will be available on my website afterwards. I've got detailed references in some of the notes if you want to explore some of these areas further. I work as a principal consultant for the newly formed Telstra Purple. Prior to this, a better known maybe organisation as Redify. So when we talk about cloud computing, we're going to also need to talk about the history of a number of other things, as without these things, cloud computing really wouldn't be possible. So this morning, we're going to touch on a lot of different things. We're going to talk about some of the history of telecommunications and the internet. We're going to talk about protocols. Now, these are really important in that we're going to need some of these things in place in order to have modern day internet and cloud computing. We're going to talk about the history of computing itself and various hardware advances. And then finally, some of these things wouldn't be possible without various investments from business, and we're also going to touch on that. Now, I'm going to split this presentation into four main areas. What I'm referring to is prehistoric, and this is prehistoric in the terms of cloud computing, so I mean no comment if you were born in some of these specific areas. Moving all the way through to the future, and then we'll talk about where things might be going later on. Now, I should probably begin with some sort of definition as to what cloud computing is in order that we can get everyone on the same page. I kind of like Microsoft's definition, and they say, simply put, cloud computing is the delivery of computing services, including servers, storages, databases, networking, software analytics, and intelligence over the internet or the cloud to offer faster innovation, flexible resources, and economies of scale. So this morning, when I'm using the term cloud computing, I'm talking about everything from running infrastructure in the cloud, functions in the cloud, software, all of it. We're going to talk a little bit about all these things this morning. Before we delve into this, I want to talk about something called the narrative fallacy. And this refers to a tendency that as human beings, we love stories. Stories are great. They help us communicate things and they help us understand things. Now, we also like to naturally believe that B follows A and C follows B, and that there's kind of this linear progression of things. Where this can go wrong, however, is that sometimes it can increase what we think our level of understanding of some of these concepts are. Now, the reality of this presentation is that I've got about an hour or so to cover a heap of things. I've had to pick various items and then try and weave this into some kind of tale for you this morning. So just be aware that there's very many more things than I'm going to be talking about this morning, that all, if you map them out, there'll be this kind of, all these sort of wiggly lines intersecting and so on, which all go and contribute to where we are today. So how did cloud computing begin? Well, we could probably begin with Mr. Charles Babbage and his analytical engine. But if we start at this point, whilst very interesting early computer history, we're going to be here all day. So I'm going to have to skip over some of these things. So sorry, Mr. Charles, we won't be talking about you today. And we won't be talking about the work of Ada Lovelace and a huge number of other characters, which will also create various innovations and developments that will all be necessary for cloud computing. Let's go into what I'm going to refer to as the prehistoric cloud computing era. Now, for me, I think these things started off around the Cold War. This is a period in the 1950s, and there's this conflict between, at the time, the Soviet Union, various satellite states, and the US. And it's a Cold War in that there's never any direct Russian soldiers shooting American soldiers, but each side are supporting various initiatives that will impact or hurt the other in some way. Maybe they're supporting various regimes which have interests in their favour. And there's a heap of sort of espionage and things going on behind the scenes here. Now, at this point in time, the Americans very much believe they're the technical superpower of the day. They believe they have the most advanced science, the most advanced scientists, engineers, and so on, and that they're leading the world in these type of developments. So it comes as something of a surprise to them when they hear this sound. Does anyone know what this sound is? That's all right. So the Russians succeed in putting a satellite into low orbit in 1957. And this shatters the Americans' perception that they're the most technically advanced race at this point. And this creates a bit of a problem for the administration. Under the Eisenhower administration, the focus of American government changes, and various funding is put into science and technology programs. It's going to have massive impact, this launch of this satellite. And one of the things that comes out of this is the organisation NASA. Of course, NASA focused on all things space. Now, the one we're interested in this instance, however, is ARPA, and that's the Advanced Research and Projects Agency. It's later going to be renamed DARPA, or the Defence Advanced Research and Projects Agency. And the purpose of this is that it's formed for forming and executing research and development projects to expand the frontiers of technology and science and able to reach far beyond immediate military requirements. So, what's going on in the world of networking and so on at this time? Well, 1958 sees the introduction of modems. And modems convert digital data to and from sounds. And these are important because this allows existing telecoms infrastructure to be used to actually go and transmit data between different machines. There's also an argument that there was something which could arguably be classified a modem a little bit earlier, which was an encrypted communication system. The Americans set about building this thing called SAGE, which is a semi-automatic ground environment. Now, the purpose of this massive thing here is that it's going to provide a unified view of the airfield. And so it's going to track up to 400 or so Russian bombers, which theoretically could be coming over to bomb the United States. Of course, any nation capable of putting a satellite into orbit could theoretically launch missiles, which is what the Americans are afraid of at this time. So this thing here houses one of the largest computers ever built, the ANFSQ-7 at 22,000 foot. It's an enormous amount of money to develop, and costing $61 billion in development over 6 years. It's also made up of 23 different buildings that are all feeding in various sort of information about, you know, where these bombers and so are. So I think we see a very early example here of kind of a distributed system here. All of this is linked together via modems. Now, SAGE is also going to be used for commercial use, one of the first airline booking systems later on. But let's go back. There's a guy called Paul Barron, and he's becoming concerned that communications could be taken out for many hours by nuclear attack. And he sets about designing a survivable communication system. If we consider this central node here, this yellow node here, as routing various communications, if this was to take out, then these other 4 blue dots could not talk to one another. So Paul's interested in this, and he puts forward that if you create additional connections, and he puts forward the idea that if there are at least 3 connections between nodes, even in the event of a 50% loss of nodes, it's going to still end up being a survivable communication system. And this stuff and these ideas are important because they're going to lead to something called packet switching, which is going to lead to reliable communications in the internet later. So there's kind of this myth kicking around that you've probably heard, that the internet was designed to survive nuclear war. I want to read out part of a quote from a guy called Charles Hertzfeld, who's one of the directors at ARPA. And he says, the ARPANET was not started to create a command and control system that would survive a nuclear attack, as many now claim. To build such a system was clearly a major military need, but it was not ARPA's mission to do this. In fact, we would have been severely criticised had we tried. Rather, the ARPANET came out of our frustration that there were only a limited number of large, powerful research computers in the country, and that many research investigators who should have access to them were geographically separated from them. So this, we'll get on to this in a minute, but this system and network is not created around a survivable communication system. This is not the motivations for this. I want to introduce you to this guy because he's going to be very important in the development of the internet and cloud computing. And this is JCR Licklider. He liked to be called Lick, which is very much easier to pronounce, so I'm going to go with that. And Lick has a background in something called psychoacoustics. Lick is very interested in how sounds get interpreted by the ear and understood by the brain. And he starts to put forward some really important ideas. And one of the things that's quite important is at this point it looks like everyone's handing over decision making to computers because computers could perform certain types of decisions very much quicker. And Lick puts forward this idea that actually we can make some better decisions if we involve humans in this decision-making process. So Lick is hired to connect a number of Department of Defense computers. And during this period, he comes up with this concept called the Intergalactic Computer Network in 1960. I'm going to read this out because this is absolutely pivotal to some future development. And he says, it seems reasonable to envisage for a time 10 or 15 years hence a thinking centre that will incorporate the functions of present-day libraries together with anticipated advances in information storage and retrieval. This picture readily enlarges itself into a network of such centres, connected to one another by wideband communication lines and to individual users by leased wire services. In such a system, the speed of the computers will be balanced and the cost of gigantic memories and sophisticated programs will be divided by the number of users. Now, does that sound like a couple of modern day services? And bear in mind, these ideas are absolutely revolutionary. This is 1960. None of the technology currently exists in order to implement and build some of these ideas here. I think there's a strong argument that we could consider Lick the father of the internet and indeed cloud computing. So we move forward in time to 1963, and Lick's now become head of the behavioural sciences and command and control programs at ARPA. And he starts talking about these ideas of this intergalactic network with some of his colleagues. And he convinces a couple of his colleagues, Ivan Sutherland and Bob Daler, that this thing's really important and we need to focus on this as an organisation. And so this is going to lead to the creation of ARPANET. Now, current state-of-the-art computing is that thing over there on the left. That beauty over there is the IBM 1442 card punch machine. And when people want to go and schedule various programs to be run, it requires a specialist operator who will order up these punched cards programs and feed into this machine. People start coming to the realization that maybe we're not making full usage of computers at this point. And people like John Backus start considering this concept of time sharing. And we can see here in this quote from 1958 that we start seeing this idea of computing and processing as kind of a utility. Organisations would have input-output equipment installed on their own premises and would buy time on a computer, much the same way that the average household buys power and water from utility companies. 1958, these ideas are being put forward. So it takes a bit of time before we start getting a modern-day time-sharing operating system. And this is a really difficult problem at the time. Very limited hardware, and it's a very tough problem because as you go and switch between different applications or programs, you're going to need to store the state of what these things are somewhere. But this is eventually solved with the introduction of the first time-sharing system, CTSS, by John McCarthy at MIT. And later we see DTSS, or the Dartmouth time-sharing system, released 3 or 4 years later in 1963. There's an important project going on over at an ARPA-funded project researching various aspects of computing. And they want to look at things like AI, computational theory, and so on. And the academics put forward all of these ideas, but they realized that at the time, current hardware is not going to support and be able to run some of these sort of revolutionary ideas. So they put out a proposal to the largest hardware manufacturers at the time, which are General Electric and IBM, and they say, hey, we need to help building these ideas of ours. IBM responds saying they didn't want to develop a time-sharing computer as they did not feel there was big enough demand. They did kind of redeem themselves later with the introduction of the first mainframe to support virtualization. But this Project Mac is going to make some important contributions to computing history. But we've got this idea of this network now, but it's not been built. It's all in theory, it's all in people's heads, and it's going to need to be built. So they put out this proposal to some of the contractors of the day, but it's seen as crazy. Like, no one's done this stuff and built this large-scale network before. So people aren't so keen in potentially building this. But it will eventually be built by an organization called BBN, or Bolt, Bernick and Newman. And they set about connecting one computer in Utah with 3 over in California. Now, they want to do this because it's all about sharing of scientific information. And then one fateful evening in 1969, via this new network that's recently been built, they successfully managed to transmit the first word. And they transmit login, and by Charlie Klein at 10:30. And he sends this from UCLA to the Stanford Research Institute, or SRI. Although he doesn't actually send login, because it crashes after they send the first two letters there. So the first word is actually LO. You can theorize that maybe he was sending LOL, but who knows? They do eventually get this working a couple of hours later, though, and the word is successfully transmitted. And they're on the phone to each other saying, can you see the L? Can you see the O? And you can imagine the excitement at the time. I think, and this is a picture of the log here, and it's kind of understated in that, this hasn't been done using this network before. Talk to SRI, host to host, 1030 there. Now, ARPANET, it's not the easiest thing to use, and it's all academics using this thing. It's focused on the sharing of scientific information. And the knowledge of how to use it is spread very much by people. It's academics moving from university to college, moving around the place and saying, this is how you work with this, introducing other academics to some of the facilities. And they've got this problem at the moment that it's really hard to go and make improvements to the network. So they set up this thing called a network working group. And out of this, we get the RFC process, which we still use today. They introduce a protocol called NCP, or Network Control Protocol, which is going to make it easier to communicate between some of these machines. 1969 sees Compuserve founded. I think Compuserve are probably better known as an ISP, but they're actually founded way back in 1969. And they're founded in order to provide computer processing support to an insurance company. And I think they're also one of the first people, they noticed that their machine, a lot of the time, very expensive hardware at this time, isn't actually doing anything. So they go and sell this to other corporations later. What else is going on? Well, there's a number of other networks in development around the world here. We see the introduction of the MPL network in the UK, AloaNet in Hawaii, HLN for a consortium of airlines, and also another one called Cyclades, which is going to be quite influential to what will become the internet. So as we move on from prehistoric cloud era, we've now got reliable telephone line-based communications. We have modems. We have an RFC process. I really can't emphasize how important this RFC process is going to be. This is going to be an important way to establish and share new ideas. We're very much in the era of expensive mainframes as well. And computers are currently costing around $5 million or so. So only very large organizations can afford to purchase some of these machines. The network at the moment is solely focused on academic and government use. Commercial use is absolutely out the picture at the moment. Let us move on to Cloud Middle Ages, or the period between 1970 and 1990. So this diagram here shows the development of the ARPANET here. And you can see between the period of 1969 and 1977 how quickly this network's going to grow as we start seeing the linking up of various educational and sort of government establishments here. They run a demo, and it must have been absolutely amazing at the time, where they go and demonstrate network traffic, remote login, editing a text file, and a computer mouse. But ARPA's focus is not on running a network, but that's what's starting to take up an increasing amount of their time and resources as people find this a useful thing. So the Defense Communications Agency end up taking control of ARPANET in 1975. 1977, we see what's known as the first commercial local network at Chase Manhattan Bank in New York, using a token ring architecture and apparently able to support up to 255 computers. Personal computers, they start to become affordable. Somewhat expensive in terms of between $4,000 and $5,000 US dollars in modern day adjusted terms, but they're just about in reach of maybe some more wealthy individuals here. Change root command, I think, is an important one that's worth mentioning, that's introduced in 1979. Now, this is a Unix-based command that allows you to change the root directory for a running process and its children. And this is the beginning of being able to isolate programs of different file systems. And some of these approaches and developments are going to lead to later things such as containers, Kubernetes, and so on, that we're kind of starting to take for granted today. Now, at the moment, ARPANET machines, they're using a protocol called 1822 in order to talk to one another. Has anyone heard of that protocol? No? It's not one I'd come across either. And the other main protocol they're using is NCP. But these protocols have an issue. They're not very good. They're very good for talking direct from one host to another. But when you start linking networks together and networks of networks or internetworks, they have some problems here. So a different approach and solution is needed. So in 1983, we see TCP/IP replacing NCP as ARPANET's main protocol, with TCP/IP being developed by Vint Cerf and Bob Kahn. 1983, we see the introduction of DNS from Paul Mockapetris and John Postel. And the important thing about these protocols is that we can now hide the differences between all these disparate networks by their abstractions. Now, around 1983, the military starts to become a little bit concerned with the potential security issues around the use of ARPANET. So they spin off this other network called MILNET, and this contains some additional protections such as encryption and so on. Now, around this time, a number of other organizations start developing their own networks, including the National Science Foundation, NSF, and they'll develop something called NSFNet, NASA, Department of Energy, and all of these things will eventually become the modern day internet. And somewhat sadly, we see the decommissioning of ARPANET in 1989. Now, I came across this quote here, and this is by an MIT member of staff. And they start to become concerned that what people are going to use or are using ARPANET for. And they say that sending electronic mail over ARPANET for commercial profit or political purposes is both antisocial and illegal. By sending such messages, you can offend many people, and it's possible to get MIT in serious trouble with the government agencies which manage the ARPANET. So bear in mind, all of these things, academic and government focus at the time, it's sort of the idea of these things being used for commercial use is a scary idea for these people. Of course, we know how that's going to end out. 1989 sees the creation of the world's first ISP by a New Jersey-based company, and they introduced this ISP called The World. And this is controversial at the time because no one's done this before, and a number of different governments and universities threatened to block access from The World because, you know, on the grounds that this network was not intended for commercial use. Over in Australia, we see the registration of the AU top-level domain to Kevin Ells at Melbourne University. And Australia gets its own ISPs, which, depending on who you talk to, is probably either Dialects or Pegasus Network Foundation over in 1989. This is the era of the early internet services. We're seeing the establishment of various ISPs such as Compuserve, Prodigy, AOL are sending out their disks to everyone. But at the moment, some of this stuff is not very easy to use, and it's not really doing what people want. But this is about to change with the work of this guy. So Tim Berners-Lee, or Sir Tim, whilst at CERN in Switzerland, he creates a couple of proposals, and these are going to go on to become the World Wide Web in 1989. And I think you can argue that he combined hypertext, TCP/IP, and DNS in order to create the World Wide Web. And on Christmas 1990, he has a running prototype of this on a Next computer. Now, it's going to take a little bit of time before this is sort of starts to reach outside academic circles. So as we move on from this sort of Middle Ages of cloud, we've got reliable and fast comms infrastructure. We've got essential protocols, TCP/IP, DNS, HTTP. We still use these today. These are almost 40 years old, some of these protocols. A really important factor for us, however, is that developments in processing power and computers means that computers are now affordable to individuals, and they're costing around $1,200 depending on what you're buying. Now, if you need to do any sort of hosting of network and stuff, it's been done in-house. You've probably got some kind of server in a cupboard somewhere in your company. Let us move on to modern day cloud computing. So this graph here, this is from the American Census Bureau. That purple line there represents people that have a computer, and that blue line there represents computers with an internet subscription. The other lines there are from a similar survey. And what you can see over here is that round about this period, 97, 2000, this is about to increase dramatically, all the way up to, and this ends 2015 here, where we have about 80% of households with a computer and internet connection. And I'd guess that it's probably going to be even higher today. So we're about to see a huge increase in terms of computers and demand on the internet. The internet's not the easiest thing to use at the moment, but this changes with the release of Mosaic in 1993. And the great thing about this is that it's really easy to use, and it also displays multimedia content. It's not just plain text anymore. So this is going to excite a number of people. Bill Gates. So Bill's watching what's happening with this, and there's no doubt that Bill's a very clever guy, and he releases something that's known as the Internet Tidal Wave Memo. I'd encourage you to Google this, as it makes quite interesting reading. It kind of starts off with Bill has a somewhat bit of a rant, to be honest, where he can't find any Microsoft formats on the internet. He can't find, which is somewhat entertaining. But look, Bill's a clever guy, and he starts to get an idea of where things are going at this point. And I pulled out a couple of comments there. We need to understand how to make NT boxes the highest performance HTTP servers. Our server offerings need to beat what Netscape is doing, including billing and security support. There'll be substantial demand for high transaction servers. So Bill can see where this stuff is going. I think there's an argument over whether Microsoft were able to execute on this for a while, but way back in 1995, Bill can see where this is likely going. This is the era of the dot-com boom. It's very easy to raise money for companies. There's a lot of potential in terms of an increased number of people using the internet, increased number of devices, internet users, and so on. And then there's also a number of combination of other factors, such as low interest rates, lowered capital gains tax, and so on, that make it really easy to get some money. And of course, we also have investors maybe ignoring some traditional business metrics, such as cash flow. People maybe get a little bit excited and greedy. There's massive infrastructure investments going on as well at this time. People see where things are going here and anticipate a huge demand. We see the largest ever IPO at this time, with Netscape launching with a value of $2.9 billion. Jeff Bezos. So there's a guy called Jeff, and he founds an organization called Cadabra.inc. And the story is that Jeff's solicitor looked at this name and mistook it for cadaver and said, look, company named after a dead body, that's maybe not the best name for your company. And they have a think about this, and they decide they're going to go and rename their organization. Jeff quite likes the name Relentless, but they do end up settling on Amazon. And the rumor is that they quite liked Amazon because A, it appears at the top of the list, and A to Z. So at this point, Amazon is focused on selling books online. That is what Jeff wants to do. He has no other ideas. He just wants to sell books online at this point. And of course, he's going to later expand that out into other areas. We see the earliest use, or the earliest known use, of the term cloud computing in 1996 by a guy called George Favallo, and he puts forward this business plan for Compaq, where he uses this term. At this point, when you buy a bit of software, it's like buying a product from the shelf. So you might remember some of this. There was no real sort of subscription or licensing model. You'd go to a store, you'd hand your money over, you'd get your software, and that would be it. You would own that software here. Now, this is about to be real change. And while Salesforce certainly weren't the first people to try this model, I think they were arguably the first really successful company to put forward that actually a subscription model can work in order to go and sell software. And they're still very much successful today. We start seeing increased mobile usage at this point in time. And it gets to the point where pretty much everyone has a mobile. Your parents have a mobile. You probably remember this in your own lifetime. And all of this is starting to create increased demand for services and so on. Prior to this, computers, they weren't affordable. Now they're affordable. And now we've also got mobiles, and we've got increasing devices here. And we're putting more and more load and demand on some of the services that we're using. Of course, in the early days of sort of mobile internet, the services were somewhat crappy, and you might remember some of those text-based, was it WAP sites? I think so. At this point, hosting, we're in the era of large data centers, and the way it might work is you might go and place an order with Dell or Compaq, and it would take somewhere between 8 and 12 weeks and then you'd get a server either directly or you'd go and install it in the hosting center yourself. And I remember driving out to various hosting centers and putting servers in the rack. This isn't the quickest process. You know, that's a 3-month lead time for some of these things, and it's really not going to work for some of these organizations. And with all these increasing people having internet access and so on, there's increasing demands here at the time. So we're going to need another way of keeping up with this. And we're now at the period around sort of 2000, 2001. And as we know with any sort of increase or boom, at some point that's also going to decline. And sooner or later, the dot-com bubble does, of course, burst. And by the end of this bubble, analysts will estimate between $5 and $7 trillion will be lost. Although I think there's an argument as to whether this actually existed in the first place out of people's head. So what happened? Well, that could certainly be the subject of a presentation itself. But largely speaking, I think companies were probably overvalued. People had used metrics that ignored cash flow. And then we had a heap of other things such as changes in interest rates, Japanese recession, accountants and directors doing dodgy things at World.com and Enron, and of course the September 11 events around this period. But the output of this is that there's a lot less money around for people to go and invest with and build companies with. Investors are very cautious now. It's no longer enough that you've got a .com in your name in order to go and get a lot of money. We see large layoffs of tech staff and increasing focus on the bottom line. Amazon at this point are focused on creating something called merchant.com. And this is kind of going to be a shopping engine. And the idea is they're going to handle some of your ordering, processing, and some of the logistics around this. Somewhat ironically, they're trying to sell it to, I believe, people like Walmart at this time. And of course, Amazon and Walmart will become kind of arch enemies in what they do later. But Amazon is growing really quickly. The company's expanded far beyond selling just books at this point in time. And they're saying going into a lot of other markets and so on. But they've kind of come across this classic problem that we all know, that you can't just increase the speed of development by adding additional developers to a project. It just doesn't work. And they set about start splitting their code base into independent services. And we see sort of very early sort of approaches to sort of service-oriented architecture and so on around this. There's kind of this myth that AWS came out of unused infrastructure, that maybe Jeff or one of his team looked around and he said, I've got all these servers sitting around and they're not being used. Hey, we can make some money out of selling this excess capacity. This didn't actually happen. So 2 people, Chris Pinkham, pictured over on the left there, and another person called Benjamin Black, they produced this paper where they start thinking about different services you need to put together various applications. And they kind of propose an operating system for the internet. And they put forward this proposal to the organization, suggesting that they could generate revenue from this infrastructure back in 2003. And Jeff Bezos says, we've realized we could contribute all of the key components of that internet operating system. And with that, we went to pursue this much broader mission, which is AWS today, which is really to allow any organization or company or any developer to run their technology applications on top of our technology infrastructure platform. And I think this is important because I think that AWS probably allowed a number of companies to exist which wouldn't have been possible without a different sort of payment model for their services. Prior to this, you would have needed an enormous amount of money to go and buy physical machines and so on. And you kind of get like this sort of vicious cycle where in order to get more investment, you're going to need to demonstrate you've got more customers, and you can't do that because you need more money in order to purchase more hosting equipment and not have your servers fall over and so on. So yes, I think AWS, if we didn't have AWS or something similar, a number of companies wouldn't exist today. So they launched a service called SQS, Simple Queue Service, which is obviously still around today, way back in 2004. And by 2006, they've kind of got their main offerings of simple storage, or S3, and Elastic Compute Cloud. And this launched in a US market first of all, with the rest of the world a little bit later. And by 2010, all of Amazon's infrastructure is running on the AWS services. Now, as we know, Amazon's a hugely popular site, and this sort of dog fooding of their own services enables them to, focus on the developing a very reliable, high-performance infrastructure. 2008 sees the launch of Google Cloud with App Engine. Whilst it has some use, I don't think it ever really sort of receives the popularity of some of the other cloud-based services. 2009, who's heard of Alibaba? Yep. So Alibaba, world's largest retailer and commerce company, and they've got a huge need for servers and hosting equipment, and they very, very large, but mostly in China at this perspective. Now, I think these guys are one to watch at the moment, and I'll come back to this shortly. But you might be asking, what is Microsoft doing in all this? Like, enormous company with enormous resources. All these other competitors have launched. What are they up to? Well, in about 2007, corporate VP Amitabh Shrivastava, apologies for your pronunciation of your name, he's asked and tasked to create a cloud platform. And he recruits some real heavyweights, including David Cutler, the father of NT and VMS system. And they create this thing called Project Red Dog. Now, the rumor is that Red Dog refers to some dodgy bar that some of the team frequented. And you can still see mention of Red Dog if you go and spin up a VM. In the computer name there, you'll see the prefix RD at the beginning. So it still sort of has its origins over there. Now, Azure won't be released till 2010, and it begins as a fork of the Windows Server 2008 operating system. Microsoft's kind of unique in that they own and develop an operating system, so it makes sense to use this. But it doesn't have all the capabilities that they need in order to run a cloud computing platform. So the team set about adding a few things to it, including a programming model, support for booting from VHD, and support for 8-core machines. Now, at this point, it's a fork of the 2008 code base. And as we know, that's going to be quite expensive to maintain. So it's later going to come back in line with Server 2012. Ray Ozzie announces Azure at PDC in 2008, but we don't see Windows Azure officially released publicly to 2010. And that's a full 4 years after Amazon have sort of released its foundational services. So Microsoft are definitely a little bit slow coming to this game there. Kind of realizing that they're going to want to host some other things, they've renamed Windows Azure to Microsoft Azure later in 2014. And I think we see quite a change in Microsoft direction under Satya Nadella's leadership when he takes over. And we started to see Microsoft embracing various competitors' products. And you might have seen some of the news that the most used operating system on Azure is now Linux-based. Azure is also interesting in that it appeals to some Amazon competitors. If you're someone like Walmart, it doesn't really make sense for you to be giving Amazon money by hosting your stuff on AWS. 2013, we see the release of Docker and Kubernetes. Now, I think these are important technologies because this is the beginning of being able to abstract extract the hosting of various services. And this brings us up to today. So in terms of current trends, as a consultant, we get the chance to work with a lot of different organizations, and these are some of the things that I see. And I've gone out to some of my colleagues, industry experts, and said, hey, what do you think's going on at the moment with some of these things? We see a trend towards multi-cloud. Now, a lot of organizations kind of end up with multi-cloud, whether they like it or not, with people sort of spinning up various things in their own time or various services that they want to play with. But for some organizations, a multi-cloud strategy is mandated. If you're a financial organization, you need to run on more than one cloud, or a certain type of financial organization, I should say. Multi-cloud, it's hard enough to run really well on one cloud, let alone bringing in a whole different sort of heap of technologies and so on. So my own advice would be, if you don't need to, probably just focus on the one cloud, get that right initially before you start introducing these. And of course, people hope to gain various things by running on multiple clouds, such as increased redundancy, the ability to negotiate price with vendors. There's kind of this fear that when a vendor sees that you're running all your stuff on one cloud, that you won't have any room for price negotiation and so on. We're seeing increased use of abstractions. People don't want to be looking after the infrastructure themselves. You no doubt come across serverless architecture approaches and so on. Competitors embracing each other's technology. I was reading this week about some offerings on AWS to make it improve support for .NET. I think Azure's kind of like the default choice if you've got a .NET application, and it's a good choice. Microsoft make it very tempting with some of the tooling and capabilities. But whilst you can certainly run .NET applications on AWS, it's maybe not quite as easy until sort of recent .NET Core stuff. Managing cost in cloud at an enterprise level is really hard, especially if you're running on multiple clouds. And I think there's going to be a need for better focus of this. And I also suspect if some organizations looked at just how much they were spending on cloud in detail, they might want to maybe spend a bit of time looking at what's actually running there. I think we're going to see as well increased legislation and even government interference in some areas, such as backdoors and so on, in order to access data. If we were to ask who has the biggest cloud at the moment, one answer would be Microsoft. And I say one answer because whilst they report the highest level of revenue, and this is back in 2018, when Microsoft go and talk about how much they make from cloud, they also lump in a number of other services such as Office 365, LinkedIn, and so on. And you can go and download their annual report and look in detail at some of these things. Now, whilst these services, yes, some of these are delivered over the cloud and they're cloud-based services, if you're in terms of being able to compare sort of infrastructure, I'm not sure really they should be included in there. And you know that winner there is undoubtedly Amazon, as reported by multiple analysts. I don't think it ultimately matters but what I do think I want to draw your attention to is that there's still rather a lot of stuff not running in the cloud. And there's probably a number of different applications which are starting to reach end of life around about now. And there might be a good opportunity to go and move some of these things to the cloud. The cloud probably didn't exist when some of these things were created in the first place. Whilst the initial sort of focus of various cloud-based businesses was very much on infrastructure, I think this is starting to turn towards data, whether it's the storage of your data, performing analytics on your data, or the management of your data. And two people I would watch in this area are IBM and Alibaba Cloud. Now, Alibaba in particular, I think are going to be particularly interesting, some of the things they're doing in this area. Some of you might have seen some of their visual pay and recognition stuff. They have a massive investment in this space at the moment. IBM, they've got some very mature products such as Watson and so on. And so whilst these are maybe probably not so well known names in the cloud world, I would watch what these people are doing at the moment. In fact, with Alibaba, we see Alibaba actually releasing and unveiling their own AI-focused chip here. So we now have an e-commerce giant, cloud hosting company actually releasing their own hardware focused on AI and visual processing here. And that's kind of cool. But what do we have in store for the future? Well, you've probably come across this quote here where we ask, why is studying history important in the first place? And you've probably come across some variation of this, in that those who cannot remember the past are condemned to repeat it. Or perhaps, as Stephen Hawking more cynically puts it, we spend a great deal of time studying history, which, let's face it, is mostly the history of stupidity. I'd like to introduce you to this model I came across fairly recently, and this is the futures cone. And what this demonstrates is that if we took a concept such as landing on the moon, at one point prior to this being done, this is considered an impossible activity. It's so far out there in terms of the realms of possibility that it sounds an absolutely crazy idea if we're going to start talking about doing this. But of course, we know now that it is possible and that people can land on the moon, and from that, a number of other things are possible. If we were to extend this path here, we can see some of the current trends around multi-cloud, increased use of abstractions, containers, and so on. And we can probably extend out to where that's going to some degree. We see the introduction from Google Cloud of Anthos, a platform to make some of this stuff easier. I think that's probably going to be a focus of a number of organizations. But what we sometimes have as well is we have these wildcard things that really sort of, can have an influence and change where things are going in terms of a direction. Things like the introduction of containers, while it was built on a heap of technology, it took a while before people really understood the implications, and this was popularized through the use of things like Docker and so on. But that obviously has a big potential to very much change the direction of where these things are going. We've seen that many different factors have influenced the development of the cloud. We've talked about various scientific and technical advances. We've talked about the creation of various standards. We've talked about the worldwide economy. We had the dot-com boom. We have people buying more computers. We have demanding to go and use some of these services. There's also need. Like, a lot of this was driven by academics early in the picture wanting to share information between one another and not really having access to the resources that they needed in order to do their work. They want to be sharing their experiments with people, so they start looking at what's the solution for this. We also see various changes in legislation around the opening up of infrastructure and so on. If I was going to pick one that had maybe the biggest influence in terms of the development, I think it's this need one. Like, a lot of this has come out of a genuine need or perhaps perceived need for a solution here. But the interaction of all of these factors is what makes it hard to actually predict where this is going. And this is a simplified picture that I've given you this morning. But let's have a go anyway. So let's have top 7 predictions as where some of this stuff is going. I think there's very much a need to abstract cloud services. I think there's now kind of a core set of capabilities that all cloud providers have, whilst there's various differences between them. There's always some type of compute, there's always some type of storage, and there's always some type of message queue or function to operate on these things. It would be very much easier if there was an abstraction to go and work with these things. And I know we're seeing the development of some of these things with various libraries and frameworks, but I think there's work to do. I think we're going to want to move data between some of these services. You might have everything sitting on Azure now, but you want to use Google's BigQuery. And right now, there's not really a good way to go and move data around between some of these services. Currently, it's very much up to you to suggest what's the right configuration for your workload and services. I think we're in the early days of some intelligence around this, but I think companies at the moment don't really have a clear picture of just how much some of these services are costing them. And that we might see some intelligence around this where Azure or AWS or whatever your platform of host is looks at what you're doing and says, hey, we could potentially scale this down for you, or have you considered this way of doing things? Because I think customers have become more and more demanding when they realize how much money on some of these things is being spent. Efficiency of data centers, I think, is going to become increasingly important. There's this rating called PUE, and a PUE of 1 means you have a perfectly efficient data center. And we have current trends, and hopefully it will continue, where we start to look at some of the environmental impacts of some of these things. And as well as the environmental impact, there's also a cost impact in that if you can produce a very efficient data center, it means you're consuming less power and you can potentially be more profitable as well. So you might have come across some of the news around some of underwater hosted containers and so on. So it'll be interesting to see where that goes. I think it would make sense for some very large organizations to potentially run their own cloud. And some of them are maybe even doing this already. If you're a Walmart or something, whilst it's no easy feat to just set up and learn your own cloud, and these several organizations have certainly learned the lessons the hard way, I think it can make financial sense to invest in some of these rather than pay someone else to go and run in some of these things. I think we're probably going to see the rise of Alibaba Cloud here, but only for some industries. Now, there's a bit of concern, some of the stuff around Hawaii and some of the links to Chinese government and so on, which are probably going to mean that some industries or organizations won't want to put their stuff on Alibaba. But it's very, very cheap. And certainly if you've got some personal services and stuff, go have a play with it. I'd encourage you to go and have a look at it. It is still interesting though, in that it's quite early days for this. So some of the documentation feels maybe a little bit clunky. It's not the easiest thing to read and so on. So it'll be interesting to see where that goes. The AI facilities and functions that Alibaba are providing, though, I think could potentially drive uptake. I think we see that with Google Cloud, from what I've seen, that people often look at some of the products like BigQuery or whatever, And that's the one that attracts people, and then they get on to using some of the other services. Maybe it'll be the same with some of Alibaba's offerings. On-demand quantum computing, 10 years, maybe, shorter. Now, quantum computing is a category, it's going to be very, very good for a specific set of tasks. And I think it would make sense in terms of a cloud model, in terms of a cloud hosting perspective, to be able to give an Azure-based quantum computer a heap of tasks to go and perform. Because this hardware initially is likely to be very, very expensive and specialist. Finally, I think it's probably only a matter of time before we see a large-scale compromise of a public cloud. Despite all the controls and everything put in place, at some point this will likely happen. And it's likely to be through some vector that we don't see right now. And this is quite terrifying, because if someone was to maybe compromise something, one of the large clouds, theoretically they could turn it against another large cloud as well. And it could be absolute chaos in terms of the damage that could be done. Hopefully that won't happen, but I certainly think it's a possibility. In summary, I'm going to propose that modern day cloud computing probably started around the Cold War period and was driven from this. We've seen how many different disparate factors have contributed to the development of cloud computing. I think the changes have largely been driven by a need of people and academics to share information and to respond to requests. And I think we can also see, with the benefit of hindsight, that if you were to see all these things happening at the time, then it'd be very hard to predict where things are going in the future. I'm going to end there. Thank you very much. Does anyone have any questions?
Why do you think Google wasn't as successful as, say, Microsoft? Why have they fallen behind?
Probably a number of factors. I think Microsoft had a number of advantages. Whether it was owning the .NET development system, so they could immediately encourage sort of uptake via those routes. I think they invested a huge amount of money in making things like Azure very easy to use. I didn't see that from Google. I remember, and maybe it was just some of their sort of conferences and groups that I frequented, that you'd see a very noticeable presence from Microsoft encouraging people to get on this. They introduced various programs for small businesses. There was a lot of sort of investment and focus in that direction. And I just didn't see that from Google. They seem to be sort of taking a slower route, or maybe focused in a slightly different area, focusing on the data stuff. What do you think?
I didn't have an opinion. I was curious because I wondered if Google's a good option to even.
Yeah, and I think Google's got a really interesting strategy at the moment. So Microsoft or AWS tend to say, put everything on us, everything on us. Now, Google have realized they're playing catch up to some degree. And the strategy they seem to be employing, in my opinion, is that we can also be your cloud. It's not a either or. And for those industries in particular where you need to be hosting on multiple clouds, Google have kind of gone in with this approach that, hey, you can also put our stuff, and we're going to make it really easy for you to run on our cloud. There's a product called Amphos that sort of it is released now, but it sort of still seems to be in development, which is supposed to make it very much easier to run and shift containers between different hosting providers, including eventually Amazon, Microsoft, and so on.
You mentioned that a potential future would be on-demand quantum computation. Do you have any idea of the kind of workloads that we might see on quantum computing?
Well, look, quantum computing, I'm certainly no expert in this area. It's very suited to a very specific type of problem. So you're not going to be running your typical sort of line of business application on it. It's going to be problems like data modeling, encryption. There's a certain type of algorithm which paralyzes, I don't know if that's the right word, but can be run very efficiently and receive sort of instant results when run on a quantum-based machine. There's a guy called John Azariah. He's on the Microsoft team working on some of this stuff. and he has a talk at the conference introducing the concepts of quantum computing. So I'd encourage you to go to that talk, and John will certainly be very happy to answer that. What I think, based on my very basic knowledge of quantum computing, we might see is, hey, we've got this data model or this computation that fits this model. Can you go and run it? That seems as sort of how it could potentially work in my head.
Do you have any comments about where you see AI fitting into cloud in the future?
Well, pretty much all of the main vendors are offering various AI-based services on demand. So Azure, AWS, they offer a huge range of AI, machine learning type stuff, everything from visual recognition, audio processing, all of these type of things. What's also interesting, I don't know about AWS so much, but you can create various models on Azure and then deploy them to an edge device. So you can take this model that you had running in the cloud and run it locally. So you might have some type of device doing some visual recognition working in the room, and you can make use of that same model that you've developed on the cloud, running on something like Azure IoT Edge.
So is it like trained on the cloud and then deployed and running on the edge?
Yep. We kind of, in the early days of, I guess, sort of hosting and so on, people might run their own servers, and there's kind of some analogies to maybe how sort of utility companies and power generation sort of developed here, in that some factories way back, they'd have their own sort of power station actually running it. And nowadays, some households, they'll have solar panels. You could potentially buy a bit of a solar grid system, which is then routed back to your home. And this kind of see this sort of similar model with cloud hosting. You can certainly still run like a server within your office building. There's some workloads that make sense to be in the cloud, and there's some workloads that make sense to be processed on the edge somewhere, and some things that kind of sort of blur some of those boundaries and sit in between. And I think it's going to be the same with some of the AI stuff. It's going to depend, on your use case. There's some stuff that works great in the cloud, and there's some stuff that you're going to want sort of locally. Oh, look, it's certainly possible. Alibaba's the one that I'm interested in. They've got a huge amount of resources and funding available. There's some clunky bits at the moment. The documentation maybe in places doesn't read so well. It's had sort of limited uptake, but they have what's needed in order to, popularize that. And they also have some things to draw people in, such as some of the AI focus that they've had. In terms of other providers, none spring to mind at the moment. Has anyone else in the audience come across anything interesting that potentially looks promising? Oh. Yeah, there's some people that I think have been rather quiet in this space, like Apple. They're enormous technology company, a lot of money. I wonder.
Yeah, you mentioned about the future development being more efficient utilization of power. You mentioned that this is all driven by some sort of need and problem, right? Can you give us some idea on how much power is actually being utilized at the moment to run all this cloud?
All the infrastructure.
From all the providers.
Yeah. I've no idea. I'd have to look that up for you, but it must be enormous amounts in terms of cooling data centers, running the machines, absolutely enormous. And as I mentioned, a company could potentially become more profitable by reducing some of these consumptions and needs. If you Google PUE, that's that power rating, you'll see some of the ratings that various people have achieved. And some of these ratings, they've had to have like a sort of an independent person come and have a look at and assess this is the actual rating. And there's various sort of complications around, do you count lighting? Do you count this as, does this contribute to your PUE rating? But I think I'll try to find some resources and I'll put it out on Twitter. Well, I'm going to leave that there. I'll put the slides up. Thank you very much for joining me. Enjoy the rest of your day.